Okay, so we're going to start this particular lesson or video in the lesson off with the idea of applying some ideas about um, the different things we've learned with data. So some examples here. The data are the weights of backpacks with books in them. You sample 5 students, their weights in their backpacks are blah, blah, blah. Notice the backpacks carrying these 3 books can have different weights. Weights are quantitative, continuous. It's continuous because it can be broken down into finer parts. It's not just whole numbers. Like if the only numbers were 6, 7, 8, and it wasn't weights, it was the number of books in the data, that would be discrete. But as it's weight and it's continuous and it can be measured in finer and finer instruments or divisions, that makes it continuous. All right, the data are the areas of lawns in square feet. You sample 5 houses. The areas of the lawns are 144, 160, 190, 180, 210. What type of data is this? I think that this is a little bit tricky because I would put this down as continuous data because areas can be broken down into finer and finer measurements. And remember, when you measure things, you're looking at more than likely continuous data. Okay, it's when an area is a length by a width, and those things are measured. Okay, it's a little confusing because you might say, oh, look, this is discrete data because they're all whole numbers, but they happen to work out to be whole numbers. They could have been fractions. And example 1.7. You go to the supermarket, you purchase 3 cans of soup, 19 ounces of tomato bisque, etc., etc. Name the data sets that are quantitative, discrete, continuous, and so on and so forth. I'm going to give you a minute to do that, or a couple of minutes to do that. I'll start up it quickly on the machine, on the video. So one possible solution, there are many that you could come up with. As far as the 3 cans of soup, the number of cans of soup, the packages of nuts, the 4 kinds of vegetables, the 2 desserts, that's quantitative because it's about numbers and so on, but it's discrete because you can count them. That's the big thing with discrete data, is that they're countable. The weights, on the other hand, are continuous data. Things like the ounce weight of each of these things, okay? The ounces of the tomato bisque, the ounces of the lentil, and so on. That's because they can be measured and broken down into finer and finer intervals. Always works out to be continuous data. And then finally, the types of soups, nuts, vegetables, and so on, that would be categorical data. Okay, so that's the last one, breaks down into those. So this is a really good application of what we're talking about, a chance to apply the idea that if it's measured, it's continuous because it can get into finer and finer parts. And if it's discrete, then it's countable because it's whole numbers. Okay, let's try a couple more here. The first one, the data are the colors of houses. You sample 5 houses. The colors are white, yellow, blah, blah, blah. What type of data is this? This is qualitative or categorical, because again, it has nothing to do with numbers. Okay. Note, you may collect data as numbers and report it categorically. For example, the quiz scores for each student are recorded throughout the term. At the end of the term, the quiz scores are reported as A, B, C, D, or F. Okay, so to say that categorical or qualitative data never has numbers is not accurate, but generally speaking, it doesn't have numbers. Next, example 1.9. Work collaboratively to determine the correct data type, quantitatively or qualitatively. Indicate whether the quantitative data are continuous or discrete. Hint, data that are discrete often start with the words the number of. Okay? All right, remember, discrete data is countable, continuous is measurable, generally speaking. So you start on that. I'll give you the answers when you're done pausing this videotape. Okay, so items A, D, and G are quantitative discrete. Notice in A, the number of pairs of shoes you own, countable. D, the number of classes you take, countable. G, the number of correct answers on a quiz, countable. Quantitative, discrete is countable, okay? Next up, quantitative continuous, things that can be measured, broken down into finer and finer pieces. C, the distance it is from your home to the nearest grocery store. Distance is measured. F, the weights of sumo wrestlers, measured for sure. H, IQ scores, measured because you put it on a test. All right. Your IQ score is a measurement, and measurements are continuous data. Let's see the next one. Items B and E are qualitative. The type of car you drive, clearly that's not a numerical driven thing, so it's not quantitative. It's a category or a quality. And E, the type of calculator you use, clearly, again, not a number type of thing. I might call it calculator 1, but that would be definitely a quality. All right. Now we're going to talk about data structures and research methods in statistics. So we previously learned that there were two types of data. Well, also there are two types of data structures. There are two types of statistical data structures. Statistical research for examining the relationship between two variables. The first one is the correlation method, and the second one involves both experimental and non-experimental methods. In the correlational method, correlational research is a type of research method that involves observing two variables in order to establish a statistically corresponding relationship between them. The aim of correlational research is to identify variables that have some sort of relationship, and to the extent that they change, a change in one is linked with some kind of change in the other. For instance, a real quick idea of this is, imagine if someone ate lots and lots of cookies. You would tend to see their weight go up. So there's a correlation between the number of cookies eaten and the weight that goes up. It's not true. It doesn't cause weight for every person. Lord knows my brother-in-law can eat 5 million cookies and he doesn't gain an ounce. I think we all know somebody like that. Me, I look at a cookie and I gain weight, all right? So correlation is kind of a link between two things. Now, one could go up, the other could go up. One could go up, the other could go down, but there's a link. There's something going on between the two of them. It's also called observational studies. A correlational study will not determine cause and effect. It just says, look, as this happens, this other thing tends to also happen. It does not determine that there's a definite cause and effect. There might be, but there might not be. All right, there are two types of correlations. There's both positive and negative correlation. With positive correlation, as one goes up, the other tends to go up. For example, your hours studying and your grades. Generally speaking, the more studying you do, the higher grades you'll get. Time working out in physical condition. If you work out more, you tend to be in better shape. Time spent playing video games and the levels reached in those games. Generally speaking, the more video games you play, the higher levels you tend to reach, and also for that matter, the quicker you tend to reach them. Negative correlations. One goes up, the other one tends to go down. Time spent playing video games and your grades. At some point, the more time you spend playing video games, the lower your grades get. The amount of alcohol you consume and your ability to drive safely. Your weight and how fast you can run. It's not true that all heavy people are slow, but generally speaking, the heavier you are, the slower you run, and the lighter you are, the faster you run. Okay, so the correlational method. Here's an example of a correlation that's put on a scatter plot on this particular graph. Generally speaking, let's look. As someone wakes up later and later, generally their grades are going down. Look at the left-hand side. If they wake up at 7 o'clock, the grades tend to be higher, 3.8 average. If they wake up at 8 or 9 o'clock, you're still getting high grades. You start waking up at 10, 11, or 12 o'clock, the grades are getting lower. So there is a correlation between them. Does that mean that the grades are lower because they're waking up later? No, the grades could be lower because maybe the kids aren't studying as much who wake up later. Maybe they're just lazy kids, and when they come home every night, rather than doing some studying, they just play video games all night long, go on Snapchat, Facebook, Instagram, and talk to their buddies all night. It's not that they woke up later. It's that they never did any work. That's the real problem. Okay. Now, experimental, let me go back for a second here. It also said, I knew I missed something. Do you think this is a positive or a negative correlation? This is a negative correlation. As one gets higher and higher, the other one gets lower and lower. Notice through these dots, if I was to draw a line, we call it a line of best fit, through the middle of this graph, or a linear regression, notice how the line would be going downhill. Well, if you notice, if you remember anything about slope, when slope runs downhill, just like a downhill slope is a negative slope, likewise, a downhill correlation, if you drew the line through the middle of them, is a negative correlation. Experimental and non-experimental method. In both of these methods, for examining the relationship between two variables, there is an examination of two or more groups of scores. Like before, the first score was what time you woke up, the second score was your GPA. That's two or more groups. In the experimental method, the goal of an experiment is to demonstrate a cause and effect relationship between two variables. That is to show that changing the value of one variable causes the other one to change. This is an experimental method. Now, we said before that in correlation does not show cause and effect. This is an experiment, and this experiment is trying to demonstrate that as one goes up or down, the other will also go up or down. If you change one, you automatically change the other. That's what the experimental method is trying to show. In an experiment, one variable is manipulated to create treatment conditions. A second variable is observed and measured to obtain the score for a group of individuals in each of those treatment conditions. Example, what time you wake up or the number of hours of sleep you get, and then let's go look at the grades. The measurements are then compared to see if there are differences between the treatment conditions. All other variables are controlled to prevent them from influencing the results. That's really, really, really important. If you're trying to see, hey, does specifically the amount of time you spend working on something affect that thing, or let's say we did the amount of hours studying, they're not going to let them also change other things like the amount of hours played with video games or the amount of sleep you get and so on and so forth. We want to control everything else to make sure it's a result of just the one thing and the one thing only. Manipulation, the researcher manipulates or changes one variable and it changes its value from one level to another. And the second variable is observed or measured to determine whether or not the manipulation causes changes to occur. The researcher must exercise control over the research situation to ensure that the other extraneous variables, the other things going on there, don't influence the relationship being examined. We'll talk a little bit more about the experimental method in a second, but this video is getting pretty long.